Thank you for joining us today for the webinar, Key Points to Performance Test Strategy. We really appreciate you joining us. My name is Bob Cruz, President of Checkpoint Technologies, and today's presenter is Thomas Markunis. Thomas is a Senior Performance and Automation Engineer with Checkpoint Technologies. He has a bachelor's in Computer Science from NEIU in Chicago and has been working in the QA world for nearly 10 years, utilizing the HP Mercury tools the entire way. Thomas is certified in both ALM Quality Center as well as Unified Functional Test with QuickTest Pro, and he also possesses extensive knowledge in performance testing using HP LoadRunner. Thomas, you want to say hello to the group?
Hi, folks. I really appreciate you joining this webinar. It will be very, very useful.
Thanks, Thomas. And again, my name is Bob Cruz, President of Checkpoint Technologies. I'm a certified HP expert in the area of functional automation. I've been involved with QA and functional test automation for well over 16 years, and I have well over 24 years of IT experience. I've consulted and trained for 250 plus organizations, and I've spoken at numerous conferences worldwide on topics of test planning, test automation, and mobile testing. And I'm also very proud to be the current president of the Tampa Bay Quality Assurance Chapter. So again, thank you for joining us. And just to share with you, if Thomas happens to make a joke, if you can type in your question, just LOL or haha, it makes him feel really great. But again, thanks for joining us. A little bit about Checkpoint Technologies. We are a solutions-oriented company that provides leading-edge solutions and services in all areas of application delivery, as well as IT operations and strategy. We deliver a wide range of focus solutions, including software, hardware, short-term consulting, staff augmentation, and education. And we focus on optimizing your organization's ability to treat IT as a business. Some of the services that we provide, we actually provide quality assurance and quality control services with emphasis on functional, performance, and application security testing. We incorporated in January of 2003 in sunny Tampa, Florida. We have a 7,800 square foot test lab and training center here. And we are an HP Software Gold partner, which I'm sure many of you know is a Legacy Mercury partner. We're an HP Software Support partner and Certified Training partner. And we also have expertise in the HP ESP solutions. That's Enterprise Security Products. So we provide staff augmentation services, whether it's long-term contract services on-site or remote, such as QA leads, manual testers, automation experts, performance engineers, etc. We do consulting. So if your organization needs somebody to come in and do installation, configuration, implementation, etc., we can do that. We also provide outsourcing. As I mentioned, we have a test lab, a very large test lab here in the Tampa, Florida area, and we provide education in way of training and mentoring. So just a little bit, all of you should be seeing a webinar control panel somewhere on your screen, probably over to the right. If you want to submit any questions during the webinar, please feel free to do so. Just type your questions in the area where you see the arrow pointing to on your screen. Submit those. Thomas and I will do our very best to answer all questions during the webinar. Usually we're not able to do that because time runs out, and we respect how busy all of you are. We want to stick to the 1 hour, but we will, after the webinar, respond to all questions and then send them out via PDF within the next 2 to 3 weeks. So without any further hesitation, I'm proud to turn the presentation over to Thomas. Key points to a performance testing strategy. So Thomas, take it away.
Thank you, Bob. Hi, folks. Thank you again for joining this webinar. So let me review the agenda first. We will start with the introduction to the main topic. Then we will going to discuss why performance testing tools do not guarantee performance success, importance of creating real-world performance testing requirements, criticality of creating proper performance test plans, why implementing a proper test environment is a key, I'm going to share many tips to avoid common mistakes and pitfalls in performance testing. Then we're going to go over description of the mature performance testing team. Then obviously summary and Q&A section.
And as I mentioned before, feel free to submit questions during the presentation, but we will have a Q&A session at the end as well.
Thanks for reminding, Bob. So my experience and exposure to dozens of various organizations has shown me that there tend to be common mistakes organizations do while establishing themselves in performance testing. The majority of these mistakes tend to be around the lack of strategy, planning, and lack of experience. This presentation webinar is based on my personal observations throughout my career in performance testing, and I'll be sharing most important, in my opinion, points that was slowing down or stopping organizations or performance testing teams or even individual performance test engineers to grow and to be successful. So I hope this information will be useful for you and your organization and will help you all succeed. I have seen organizations that believe purchasing a performance testing tool is all they need to do performance testing and be successful. And I have noticed performance testing tools do not guarantee success. Let me give you an analogy that helps us understand why. The analogy I came up with is to have performance testing successful is like driving to a faraway town where your car is a performance testing tool. A driver is a performance testing engineer or team of engineers. A destination, a driving destination, is a goal of performance testing in organization. A driving traffic rules are the performance testing processes and standards. And finally, the map and directions that you need to get to your destinations in performance testing are the performance test strategy document. I will let you a few seconds to digest this analogy because the next slide will be based on it. So why performance testing tools do not guarantee your success in performance testing? I suggest to ask ourselves the following questions based on my analogy to realize the answer. Can you get to your destination if you don't have a car? Sounds like a simple question, right? But in performance testing, the same question would be, can you do a performance testing if you don't have a tool, a performance testing tool? Can you get to your destination if you don't know how to drive? Equivalent question in performance testing I would ask would be, can you do a performance testing if you don't know how to use the performance testing tool? While driving, can you get to your destination if you don't know it? You don't know where you're going. In performance testing, can you be successful if you don't know your goals or their goals are not defined? Can you drive to your destination if you don't know the traffic rules? Imagine how driving would look like without any traffic rules. It would be very chaotic, right? Same applies to performance testing. Without defined and governed processes and standards, performance testing would be barely successful. And last question, can you drive to your destination without directions or map? In performance testing, can it be successful if you don't have your strategy? Again, folks, the only reason I'm mentioning this is because we see so many organizations and companies that believe performance testing tool is all you need to do and be successful in performance testing. And as you know, as you realize by now, I hope that it's not the case. Let's talk about performance test requirements now, and you will see in a minute why those are so important to your success. I have noticed in many organizations having a hard time in performance testing due to lack of personnel having enough experience and knowledge in writing performance requirements. This and next slides actually has information for those responsible for creating performance test plans and all it takes to do it right. The first point that I want to mention when it comes to requirements, performance requirements are the foundation and starting point to most performance projects. Very important to know, and that requirements are like a foundation of the building, and as people say, you can build as high as your foundation is deep, actually. Incomplete performance requirements can lead to invalid performance test results and discovered bottlenecks and possible performance issues in production. Also, requirements must be measurable, testable, and achievable. Often I get questioned, what do you mean by saying measurable performance requirements? And that means that measurable means that they have to be specific numbers inside the requirement. For instance, the example of a simple performance requirement, a login transaction average response time should be below 4 seconds in 90% of the cases when 300 active concurrent users browsing the application. If you noticed, I mentioned 3 numbers here: below 4 seconds, 90% of the cases, and 300 active users. So those numbers make that requirement a measurable one. Let's talk about very common mistake that can have a terrible consequences and is underlooked in the industry nowadays. The load conditions in the requirements must be based on peak second conditions instead of peak hour or day. Avoid distributing peak hour load numbers into minutes or seconds by dividing those by 60 or 3,300. Let me give you an example. Let me have my water, folks.
So, you know, it's interesting in that one of the things I've always found, Thomas, even on the functional automation side, it's very seldom that an organization fails due to lack of knowledge with a solution. It tends to be due to a lack of strategy or lack of planning. So on the performance testing side, obviously the point you're making is that, you know, the strategy and planning is very important, especially around requirements. So before you continue with this slide, I do actually have a question here, if I can throw that at you, Thomas.
Sure, Bob.
So somebody asked, I'm a performance testing engineer contractor, and they got assigned to a performance testing project to test a new web-based application, but they were not provided with any performance testing requirements at all. So any suggestions in that case, Thomas?
Yeah, actually, I have experienced such situations myself, and unfortunately, this situation is not that uncommon, in many organizations, especially in the ones that are not yet advanced in performance testing area. What typically I do is I create performance expectations table for each chosen transaction, and usually I do it based on industry standards. So there is industry standards for the web applications, and you can use those numbers to create your expectations. How fast each transaction chosen to be performance tested you want to respond. If organization has no clue what kind of flow application might be getting, you have to make sure you run a stress or load test and let them know what kind of load your system can handle without crashing or slowing down to unacceptable levels of transaction response time. So, okay, Bob, do you have any further questions at this moment?
No, that was perfect, and that made perfect sense. I'm going to let you get back to and sorry for interrupting you. You had shared that great tip on load conditions, and you were about to give your examples. So I'll let you back up on that, Thomas.
Thank you, Bob. One more time, this is a very important tip. Load conditions in the requirements must be based on peak second conditions instead of peak day or peak hour. Avoid distributing peak hour load numbers into minutes or seconds by dividing by 60 or 3,600. And let me give you an example. Let's say production monitoring solution revealed that during the highest peak hour, a certain transaction was performed 3,600 times, each taking about a second to complete. I purposely made those numbers so that it's very easy to calculate, because 1 hour has 3,600 seconds. Many inexperienced performance test engineers would create a scenario with just 1 hit per second load. But in the real world, the number might vary from 0 to 1,000 or even more. The load conditions could be easily underestimated by 1,000 times. You see, folks, how critical that is. Remember, system typically crashes during the peak second, and that's why it's so important to get peak second load simulated to get a really valid results. When writing proper performance test requirements, I have noticed it's very useful to understand major types available. This slide would be very useful for those that are responsible for creating performance test requirements. Based on the type, you know what kind of measurements you should be used and mentioned in the requirement. Let's go over quickly each category and see what kind of measurements should be used for each. As you see, number 1, it's a speed type of performance requirement, and typically it verifies if system is fast enough. The most common measurements you use for this type of requirement are average transaction response times and 90th percentile transaction response time. Next requirement is stability type of performance requirement, and it usually verifies if system is stable enough. To measure such a requirement type, you use all the speed measurements plus CPU utilization, memory usage, hits per second, and throughput, and so on. Next type of performance requirement is scalability, and it typically verifies if system can handle growing amount of work in a graceful manner. To measure those type of requirements, you need all the above speed and stability measurements, but under higher expected in the future load or conditions. I would suggest those guys that are responsible for creating performance requirements, keep this slide as a reference. Let's talk now about major criteria when choosing scenarios or test cases to be performance tested. First, test case should be critical to business application or a project. Very important. The second criteria, test case should be creating the most traffic load on your system or consuming the most hardware resources. This is not always applicable for brand new applications because you don't know what kind of load it's creating yet. For this criteria, it's very useful to keep so-called 80-20 rule in mind. And the rule says that 80% of the traffic or the problems usually created by 20% of the transactions. I even tend to use 90-10 rules when 90% of the traffic is created by only 10% of the transactions. Criteria number 3, test case should fall in a list of 3 to 10 common functionalities of application under test. Next one, test case should fall in the list, number 4 is test case. If test case has a history of performance problems in the past, definitely it's a very good candidate to include in performance testing. The last criteria, nature of the application or project. This criteria is only here to point out that some performance testing projects are so unorthodox in their nature that they can be applied to some or any of those criteria. And the more criteria items your test case applies to, the stronger candidate it is for performance testing. For instance, if I have two cases picked, and one applies to 4 criteria, another one is only to 3, definitely the first one is much better candidate. Bob, at this point I'm done with the requirements. Do you have any questions related on the requirements at this moment?
No, Thomas, we're all set. I actually do have a question about a performance test plan, but why don't you go on with your other slides? I'm going to save this question for a couple of minutes, okay?
Thank you. Now I want to emphasize the importance of creating proper performance test plans. In many organizations, the need and importance of the performance test plan is still very, very underestimated. Performance test plan is part of performance testing processes and standards, and is necessary to have to reach high levels of advancement in organization. Not having them in place is not like having traffic rules defined, which leads to the chaos on the roads, as you remember from my analogy, if you're paying attention, obviously. In a moment, we will discuss what sections of performance test plan must be included to cover most important things based on my experience. As you see, the slide lists major must-have sections of performance test plan. So let's go over some of them. Risk section, and some organizations will notice they combine the risk section with the mitigation section, which, based on only my experience, it's not that useful. An objective, the main objective of the risk section is to understand involved risks and to keep release accountability. The example of risk in performance testing plan might be, for example, environment is not like production, not enough accounts created for performance tests, there is not enough time, not enough monitoring is set up, no measurable requirements, and so on. Assumption section has the main objective to make sure involved parties are on the same page. The example of the assumption might be like a DBA team will be monitored and analyze database performance during performance tests. Expectation sections has pretty much the same objective of the assumptions, but it's typically created by performance test engineer when the requirements are not detailed enough or even not present, to be honest. And usually based on the industry standards, as I mentioned earlier. In scope and out of scope sections, the purpose is to list all impacted or not impacting components. And to give you an example, for example, if you're testing application, and in most cases you have to log in. And if you log in and authentication is done involving Active Directory automatically becomes in scope system component. Even though your project may be not targeting Active Directory, but since your performance test is gonna touching it, so it becomes automatically in scope. Exit criteria section, main objective of it is to list the conditions under which the performance test is officially completed. Establish performance test success criteria. It's simply to define all performance test success criteria. There is little difference between those two, exit criteria and the success criteria. Success criteria is mostly like the performance test is being done, all requirements are verified, it looks good, and it can be finished even before UAT test even started. The exit criteria, though, usually completes in a warranty, when, for example, when the application goes into production and it has no issues in the first 2 weeks. The last section in this table, in this slide, production in QA environment differences. And the main objective is to be able to extrapolate the results and more accurately predict what they might be in production. For those that are not familiar with the word extrapolate, in performance testing, it's very, very common word, and it's just a fancy way saying that results retrieved in QA environment, how they would look like in production. That's all. So the next slide continues on the other criteria, other sections of performance test plan. List of planned performance tests, including main objectives of each and requirements each test verifying. Main objective to have clear picture what tests will be executed to verify each performance requirement. And actually, this particular section I just copy and paste into the performance final result summary report, because it's very useful even for stakeholders to see what was planned and what was executed. The next one, description and details about each planned performance test, including number of users, scripts to be used, expected to achieve load value, and so on. This is needed to have centralized details about each design performance test scenario. And this will verify that you stick to your plan when you go in your performance test. And the last one, but definitely not least, the list of reviewers and approvers of performance test plan document. This allows organization to enable work product review process and to keep release accountability. Bob, we're finishing with the test plan section, and if there is any question.
I've got a few great questions here, Thomas. One question is in regard to response time. Do you tend to use average transaction response time or 90 percentile, and why?
It might depend on the requirement. Let me maybe explain what 90th percentile mean in case some people not aware. 90th percentile number simply means that when you collect all the transaction response time, the 90% of those response times were slower and only 10% were higher. Unless requirements specify specifically, I usually use both, to be honest.
Okay.
Is there any questions I can answer?
Yeah, some other questions. What industry standards, are there any industry standards, Thomas, that you're referring to or that you would recommend for an organization to use to craft objectives and volume when there's a lack of information on the app's volume?
Yes. There is some research done, if I remember correctly, by IBM. And I'm going to send the details in an email. I don't have those with me right now. There was quite a few researches done. And every year, actually, the people get less patient. 15 years ago, the fast response time was 10 seconds, because the internet was slower. Nowadays, if I remember correctly, people believe most transactions while browsing the internet should happen under 3 seconds even. That's how they feel it's fast. People getting less and less patience because our technologies and internet gets faster and faster.
Great. So we'll answer this question in detail, and we'll recommend some industry standards, some documentation, and we'll get this out to the group. But that was a great question. Also, there's a question here that I can actually answer. We will be sending out the slides only to attendees. So all of you on the webinar today, we will send you the slides in PDF format. So we'll be give us a few days to do that, because we also want to, we're going to be working on answering all the questions and documenting the answers as well. Okay, great. Go ahead, Thomas. Continue. Thank you.
Thank you, Bob. So we're starting the next subtopic, so to speak, and let's talk about importance of environment to be used for performance testing. And here are some observations of mine. Why do you think implementing a proper test environment is a key? And my answer would be mainly to get a valid performance test results. The first bullet point, if your performance test and production environments are too much apart, your performance test results would be invalid. And later we're going to explain why. Second bullet point, the rule of thumb when it comes to performance test environments is it must be at least 50% of the production environment from size and hardware specification perspective. Otherwise, obtained results can be too far from actual. This is especially true if you're planning to run some load or stress tests. Next slide will explain you why in more details. For very business critical systems and applications where performance is critical, like for example trading systems, it is highly recommended to have production-like environment dedicated for performance testing only. Production-like environment can be very costly, obviously, but in some cases it must have things. It can be compared to having an insurance, for example. If you live in tornado zone, like we live here in Florida, it is common sense to have home insurance coverage covering tornado damage. I'm not advertising any insurance companies here, but same applies to performance testing. If your system and your application is so critical to performance, it's so important to have perfect performance, you better find the funds and get the production-like, identical to production performance test environment. One more advice I can throw that refers to this slide is, for example, if production environment has multiple instances of web and application and web servers, and like most companies have limited funding, try to obtain at least a couple instances of servers that are same in production. Well, one point just to remember though, that for example, if in production we have 10 instances of web or application servers, but only 2 in QA, the load in production database would be 5 times higher than in QA. Because as most of you know, most transactions, not all, but most, end up in a database. And therefore, the load in production will be 5 times higher because we have 10 application servers versus 2. Now I want to point out something critical that many performance test engineers are not aware. Pay attention to the graph that is displayed right now. If QA environment is weaker than production, the higher the load you apply, the more received and actual results will be apart. That's a very, very wrong assumption that most beginners, do. As you can see in the graph, if you run 400 concurrent user flow tests, you will get a 90-second response time in QA, the blue line. But the same load in production would be less than 20 seconds response time. See, there would be 70 seconds difference at 400 users load. And let's say this graph is based on QA environment that is 50% of production environment. And if it would be 40% instead of 50, the current breaking point at about 350 users would happen much sooner, much earlier in the graph, at about maybe 200 or 250 users. And the only good thing that I can think of having performance test environment weaker than production, you can always guarantee that in production the results will be at least the same but only better. So as you understand now, this is very important information to know, especially if you're planning to do more stress and load type of performance tests. So this is
Thomas, I'd like to interject if I could just for a moment, because I'm getting a few comments and questions, and rather than ask you all the questions about the same thing, I'm going to ask you to clarify something. I mean, basically, what we're saying here is that it is always a good thing when your test environment is as close to a duplicate to your production environment as possible. Because if they're significantly different environments, then you're going to have significantly different performance test results, different response times. And as a result of that, you may have to, you may start to extrapolate and estimate response times, and as we all know and everybody in the audience knows, that's a very, very risky thing to do. So did I capture the point you were just making correctly, Thomas?
Yeah, you summarized it perfectly, Bob.
Okay, great. So I hope in that process we answered some of your questions, folks. Great questions coming in. So Thomas, go ahead and continue on, okay?
Thank you, Bob. Now let me show you the list of most common performance testing mistakes based on my experience and give you some hints on how to avoid them. The most common mistakes, in my opinion, is incorrect load levels, and we already heard about it just previously in a previous slide. To avoid it, technically all we have to do is follow the provided hints in this slide and follow the best practices. Mistake number 2, tester undefined key business processes. It's happening a lot nowadays, and it happened to me as well. But to avoid this mistake, you don't let performance tester alone to decide the scope. Or in other words, performance tester should not be the one that finalizing the performance test requirement or what test cases should be included in performance test. Next mistake, too many test cases. To avoid it, you have to follow the rules when choosing test cases for performance testing. But in my opinion, based on my experience, if you have more than 15 scripts in your performance testing project, you really overcomplicate it, folks. Mistake number 4, altering load test objectives. To avoid it, you have to stick to the performance test plan if possible, otherwise officially update and reapprove the performance test plan. Since this mistake is might sound a little bit confusing, let me give you an example. Assume you ran a load test and realize the system cannot handle amount of users specified in the requirements. And let's say requirements was asking for 1,000 concurrent users. So the test failed, and so you reduced the load to 900, rerun the test, and it passed. Since results were close to passing, you decided to report as requirement met or almost met. So technically, you altered the objective of this test to verify if system can handle 1,000 users, and instead you just verified with 900. Next slide is just continues on the mistakes, on most common mistakes in performance testing. And number 5 is late focus on performance testing. Ideally, performance testing should get involved even in the beginning of the analysis phase. And in the later slides, you will understand why. Mistake number 6, transaction naming conventions. And maybe it should be poor transaction naming conventions. I've seen in my practice that such a simple mistake can completely, screw and disorganize your results. Couple of hints: you never name transaction like transaction none, transaction 1, 2, or 3, or it should be really meaningful, like login, make a payment, or something like that. Plus, another hint: if you have, let's say, 3 scripts, and there is some transactions are repeating, for example, like login. To do anything, you need to log in. The login transaction must be named exactly the same name in all 3 scripts in order to be combined in the final results. Otherwise, if you're going to have login 1, login 2, and login 3, in the results you'll see 3 transactions, but in reality you need those combined. Mistake number 7: the performance tester stands alone. Very common one in organizations that are starting in performance testing. And ideally, performance test must be a multiple team effort and a process in place how those teams work together. Very important in order to grow in performance testing for an organization. And the last mistake in this slide: over technical on results report. Your reports must be understandable to managers and your stakeholders. This is especially relevant when you're presenting a final performance test results summary to the stakeholders. You don't want your managers to be looking at huge tables with hundreds of response times and so on and be confused, Okay, now let's talk about some mistakes producing invalid results that you don't want to miss. Those are very, very important. Again, as number 1, a mistake producing invalid results, you see incorrect load levels. Because this is most common mistake, and plus it's the most common mistake when producing invalid results. Incorrect load levels as a result of averaging peak day-hour load conditions or underestimating expected load. This is exactly what I was talking about previously. There's two typical outcomes usually. Overestimated load levels usually end up in unnecessary spendings or additional or more powerful hardware. Underestimated load levels usually are much more critical and much worse. It might lead to system crashes, loss of money, or even hurt reputation of the company. Mistake producing invalid results number 2 is not applying proper noise background traffic conditions. And to explain, some people not familiar with the noise in performance testing might be, when your system or particular system component are sharing hardware with other system applications, they usually impact each other's performance. So to have that impact reflected in your performance test results, you have to find out and simulate that traffic caused by other application or process or batched up and so on. What usually I do, if the noise is less than 20%, I often choose not to bother and not include it in a test. The outcome of this mistake is it will give you a better response time than it in reality, and again it will lead to unnecessary spendings in a hardware. For those that might ask why, because if your result is showing that performance is bad, definitely organizations think they have to buy more powerful hardware, and as a result, they will be spending money purchasing it. But in reality, it's just a wrong result. Mistake producing invalid results number 3 is having performance test environment far apart from production, but reporting results as they were executed against production environment. Again, typically leads to incorrect results, worse than it would be in production, and as a result ends up in unnecessary spendings. Next slide, it just continues on those mistakes producing invalid results. Mistake number 4, incorrect performance test results extrapolation. I don't remember if I mentioned what extrapolation is, but it's just simply a fancy way of saying that converting results retrieved from QA environment and how they would look like in production. Typical outcome of this mistake is it typically leads to incorrect results that are much worse than they would be in production.
And Thomas, let me interrupt for just a moment on extrapolation, because that's something that organizations, performance testing teams should make every effort to avoid. I mean, ideally what you want to do is test in your test environment the same technical environment as production with the same number of users that you expect, the same number of peak users that you expect during your peak periods in production. You cannot safely say that the results you get, obviously, for 100 users, you can't multiply that or divide that, etc., by 10 and say this is what it will be for 1,000 users in production. So you're simply using extrapolation as a generic term, meaning to estimate based on the information that you have. And again, that's always a risky thing to do.
Yes, can agree more with you, Bob. Thank you.
Yeah, you bet. I just wanted to clarify that for our listeners. So, and you were on number 5 there, Thomas. Thank you.
Mistake producing invalid results number 5 is very, very important. It's not having enough test data created. Typically not having enough unique login accounts or test data created in a system. That's what it means. Typical outcome can produce results that look much better than actual. That's why it's so serious. And why? Because performance becomes much faster in many cases when a particular data is in a cache of database or particular server. If you have only, let's say, 10 pieces of test data and you're reusing them hundreds of thousands of times in your performance test. So it stays in a cache of your database of your web or application server, and as a result, you might get a performance that is much faster than it would be in production. So you think that performance is good, but when you deploy to production, then you see all kind of problems. So that's why number 5 is very serious. Mistake number 6 that produces invalid results. Not validating the local area network versus wide area network differences where applicable. It usually leads to incorrect results and that are much better than would be in production. This is the last slide on the performance testing mistakes. And if there is any question in this topic right now, so I would be more than happy to answer.
So Thomas, a few questions from one of our listeners. Still somewhat unclear about incorrect load levels. Are you recommending using transactions per second to avoid incorrect load levels?
To which topic this is applicable now? I'm trying to.
So again, they're asking, are you recommending that they use transactions per second to avoid incorrect load levels? You had been talking about transactions.
Definitely.
Yeah.
Definitely
Okay.
not per minute or hours or even dates.
Okay, but transactions
this
per second.
This is maybe longer answer to this question. So there's a whole topic, and I can try to answer it by email, maybe in more details.
Okay, but that is your point. You're saying that by using transactions per second, that helps avoid incorrect load levels, because if you do the transactions per minute or transactions per hour, you open yourselves up and you increase the probability that you may test with incorrect load levels, correct?
Very correct, Bob. Yeah, this is very, 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 very serious, because remember I mentioned easily the load might be underestimated by 1,000 times.
Okay, great. All right, Thomas, that's it if you want to go ahead and continue.
Okay, so next topic, so to speak. Let me share some signs and attributes of mature or advanced performance testing team. I'm sure most organizations would love to have their performance testing in this level. Those signs are the performance testing team evolves into a performance engineering team. The performance testing team starts working closely with involved team like network developers, DBA infrastructure, middleware security, and so on. When performance testing team has understanding and knowledge of all system components, that's another sign of mature performance testing team. When performance testers having enough knowledge to be classified as performance engineers. Just a reminder, performance testing is just a small part of the performance engineering field, or even science, so to speak. Instead of performance testing being part of QA, it's becoming usually part of the performance engineering, or in some organizations called capacity management or capacity planning team, which typically falls under infrastructure department. So next slide just continues the list of attributes of mature performance testing team. Performance testing team, it's getting involved in the application system and analysis and design phases. Management and involved teams understand the importance of necessity of performance testing to the effort of multiple teams working together. Based on my experience, until management gets seriously involved, the performance testing is barely possible to succeed in such organizations. The performance testing tester or performance testing team on their own, they cannot do much without the leadership support. Next bullet point is performance testing of releases in place. instead of doing just a project-based performance testing, I noticed advanced teams, they start doing performance testing of releases. Very typical sign when performance testing team getting close to be advanced. Why? Usually I ask why doing early performance testing is a beneficial, and like always answer that since many performance defects are so costly and time-consuming to fix, catching them early is obviously very beneficial. Last bullet point, performance team is able to calculate level of risk for choosing not to do performance tests. And I know this is not very not easy step to do, and to able to guarantee that application and production won't have any performance problems without doing a performance test. So the last bullet point is really only very advanced team is capable of doing it. So that would be the last slide about the mature performance testing team.
Thomas, I have a couple of questions here. What would you say are the differences between testing for projects versus testing of releases?
There is big difference. Releases, most system applications, they have the releases like monthly, every 3 months, or once a year, and sometimes there is no requirement to test, anything new when new release comes. But when performance testing team involves into performance engineering team, it's their interest. It becomes their responsibility to make sure that new release, whatever was deployed to new release, doesn't impact performance of that system. Project-based performance testing, it's simply somebody implements something new, so it's tested only once. The same thing tested only once, it meets the requirements, everybody's happy, and but in release level, same thing being retested after after each release. I hope I was clear.
Okay, great. Another question is just in regard to early performance testing. One of the points that one of our listeners is making is that if you're still getting new code in and the environment isn't stable, then that means that by testing early, one disadvantage, if you will, or one consideration is that you may end up constantly updating and revising your performance testing scripts. And this, of course, is assuming you're using, an automated solution such as LoadRunner. Is there any way to minimize, having to constantly update your scripts, Thomas, that you can share?
Actually, I like this question. When it comes to early performance test, the script, sometimes the whole script not always can be even created. Let me give an example. Developer just started working on a new application, and it's just 20% done. Let's say only authentication and some very basic few transactions are working yet, or at least they believe it's working. So, and let's say the login transaction uses a web service call to, a few web service calls to complete the whole transaction. So in this case, and it's a web application, let's say, the script would use a web protocol, for the final scripting. But in an early performance test, you just simulate those web service calls, so REST API calls, to test if they individually perform, as expected. So it's kind of breaking down, So that's also another aspect of early performance testing. It's actually a separate topic to discuss what early performance testing exactly means. A lot of things include in it.
Great. All right, Thomas, thank you.
So if you don't have any questions at this moment, the next slide would be a summary. So this completes me sharing all the points I want to share. So, and I'm positive they will help you succeed. So let's summarize the most important points we learned today. To be successful in performance testing, an organization must define and acquire performance testing tool, train the team, create or define the goals, create the processes, create standards, acquire proper performance test environment, and definitely create a strategy. Remember, without a strategy, you are like driving to a faraway town without a map or directions. I'm referring to my analogy in the beginning of the presentation. Learning how to create proper performance test requirements is another very important key. Remember, load conditions, I'm repeating this again, but very, very important. Load conditions and requirements should be based on peak second conditions instead of peak day or peak hour where applicable. Remember, load can be easily underestimated by 1,000 times or more if that mistake is done. Also, never underestimate the need of appropriate performance test plan that has all required sections. Do everything to avoid mistakes producing invalid performance test results, especially if you want to keep your job, folks. And definitely start taking steps to become an advanced performance testing team. This must be done for individuals in order to get promoted as well. So we'll finally reach the questions and answers section, and I'll be more than happy to answer all your questions that you have.
Well, Thomas, we only have a few more minutes left, but on that last bullet, that sparked a great question. What would you suggest for individuals that want to start evolving from being a performance tester to a performance engineer?
Very, very good question, and it's not instantaneous process, definitely, folks. To answer this question, I might start with a few good books that I recently ran into. I have written the title, The Foundations of Software and System Performance Engineering by Andre Bondi. That's a good book I read recently. Another book is Every Computer Performance Book by Bob Westcott. And actually, what is even more useful than books, it's going through the HP LoadRunner, in my case, user guides and best practice documents, white papers, blogs, and most important, don't be afraid to get your hands dirty. Don't be afraid to do any mistakes as long as you learn from them. So that would be my advice.
Great, great. And here's another question from our listeners, Thomas. Do you consider it important to install tools in the clients to monitor performance in production environments as well? So I'll read that again. Do you consider it important to install tools in the clients to monitor performance in production environments as well? So on the client side.
Got you, Bob, got you. Okay. Yeah, I have my own opinion on this. Good question. In my opinion, monitoring is typically useful when the results are not meeting expected response time. And to investigate what part of the system, was causing those slow response times. And I noticed since 50% of the performance testing projects don't reveal any performance testing issues, so many engineers, including me, choose to implement monitoring only if initial runs show signs of possible performance issues. And actually, this is applicable only if there is no performance stability type of requirement that's asking to verify, that, okay, the CPU and memory utilization and those type of measurements.
Great,
so to summarize
great.
my answer, okay.
Perfect. All right, Thomas. Well, it looks like we're at the end of our webinar. I'd like to thank, again, our audience for joining us today, and all of these questions are going to be answered, and we will also be sure to write down the titles of the books that Thomas had recommended. And on the next slide, you'll actually see our email addresses, Thomas's as well as mine. So please feel free to email us directly with any questions that you might have. And we certainly hope that all of you and your families have a very happy and peace-filled holiday. So again, thank you from Thomas and I for joining us. Have a great day, everybody.